After we refresh our memory on the factors of production and the production function, now we can talk about several assumptions we have to make in the Neoclassical model. Okay? And the first assumption is we're going to assume that the amount of capital and labor are fixed. Okay, so mathematically we're going to say K equals K bar. The overhead bar means it's fixed. Okay, L equals L bar. In other words, capital and labor are constant in our model. Okay, so that's the first assumption. It cannot be changed. Okay? The second assumption is the factors are fully utilized. In other words, nothing is wasted. Okay? Every unit of capital and labor is efficiently used in our production. Okay? Now, here I would leave this question for you guys. What does that mean on a PPF graph? Okay, so in our introductory course, we learned this production possibility frontier, right? So what does this assumption mean if you have to put it on the PPF graph? Okay, so during our virtual meeting, we can talk about this. Okay. Again, we're not gonna use the PPF for this chapter, okay? But I think this is a good place for us to review what we learn about the PPF, which is it could be the first graphical tool we learn in our introductory course. Okay. All right. The third assumption is a little bit more complicated, but again, if you already took the introductory course or even the intermediate microeconomics, then you should be familiar with this. Okay, so we're going to assume that our production function follows the constant returns to scale. Okay, constant returns to scale, or CRS, means a production function has a CRS if the increase of an equal percentage in all factors of production causes an increase in output of the same percentage. Now, the easy way to understand this is we can simply go with 100% increase, okay, for everything. So we're saying that if we double the amount of capital and labor, then we would find that the output is doubled as a result if the production function has CRS. Alright, so on the next slide we're gonna give you several examples, okay, the numerical ones, to help you better understand the returns to scale. Okay, basically it tells us the relationship between a change in inputs and a change in output. Okay, all right, the last assumption, the fourth one we're going to make here, is technology is also fixed. Okay, now here you already find the assumptions about capital, labor, and technology, right? Remember, we have another factor of production, which is the land, but you won't say that here because remember in the previous videos we said that most of the time we won't talk about labor in this Neoclassical model. Okay, I'm sorry, we won't talk about land because it's limited. It's not that much exciting for us. Okay, now on the basis of these four assumptions, we could draw our conclusion about the aggregate supply of all goods and services, okay, or total output. Now it's going to be like this. Okay, again, we're showing you the most general form of it. Okay, so you see this function f, and in the parentheses, k bar and l bar, as you know, the first assumption demonstrates, these are fixed, right? Actually, because we said technology is also fixed, so the function itself is also fixed. In other words, we're saying that, you know, if it's a linear function, it got to be always linear. You know, these constants, these parameters in the functions are going to be, you know, stay unchanged. Okay. Now here, because everything is fixed or assumed to be fixed, so our total output got to be fixed. That's why we get this overhead bar on the left hand side above y, the uppercase letter y. Alright, now here I also want to take this chance to talk a little bit more about making assumptions, okay, in our economic analysis. Now after we talking about these four assumptions, you might be under the impression that, you know, these assumptions are just crazy, okay, like they are totally unrealistic. How could we assume that everything is fixed? Okay, several ways you can understand these assumptions. Okay, number one, when we say everything is fixed, you can take the underlying meaning as, you know, this model built upon these assumptions is going to be a static model. Again, that's a physics term, static instead of dynamic. That means we are looking at an economy at this moment, okay, at this second. So, you know, in each second or moment, we can take everything as fixed. Okay? It might be different next second, okay, or next minute, but at this second, we could say it's fixed. The second way of looking at these assumptions is, even we suspect, you know, some of these assumptions or all of them are kind of unrealistic, but we still bear with them and trying to draw the conclusions, okay? And later, when we come up with the empirical evidence, let's see if the conclusions derived on the basis of these assumptions would be supported by our real world data, okay, or would be consistent with our data. If consistent, that probably means, you know, these assumptions are okay, okay, they're not, you know, kind of completely different from the realistic world, okay. Or if we see something different, something inconsistent between the theory and the evidence, we could come back and make any adjustment on these assumptions if necessary, okay. And sometimes we do realize that, you know, these assumptions could be oversimplified, okay. That's why among the professional economists, there's actually a joke circulating around. It says that, you know, 3 scientists, a physicist, a chemist, and an economist, you know, they took a plane, you know, flying across the Pacific, and the plane crashed, so they ended in an island where they could not find anybody else, okay? So they are trying to find something to eat to be able to survive. They actually find a canned meat, and so they start talking about how they could open the can, and then the physicist would say let's climb up on the tree and throw the can down on a rock. So if the can is broken, then we could have the meat, right? The chemist would say, hold on, we could just put the can over the fire, and when it explodes, we could have the meat. Okay. The economist said, wait a minute, let's first assume we have a can opener. That's it. Okay, that's the story. So that tells us that sometimes we could oversimplify. Okay, it is possible. Now that's actually the challenge in front of any social scientist, okay, including economists. The reason is because what we're dealing with is a human society. So there's no way we could build a laboratory and put people into the lab and do all kinds of experiments, okay? Which the chemist or physicist could do, okay? And these lab experiments or tests could help us control all other possible factors and just focus on X and Y and trying to find some causal relationship. But again, as a social scientist, we cannot do that. At least we didn't do that back in history. Okay, in the past several decades, we start doing that. It's called the behavioral economics or experimental economics. Okay, we're trying to have people come and help us do some experiments so we can make some generalized conclusion about the decision-making process in the real world. But of course, as you could imagine, even the experimental economics still suffers from some criticisms, because some economists would believe that what happens in the lab would be quite different from what happens out there in the real world. Okay, so anyway, this is our attitude towards the assumption. Okay, if you have some doubts about them, that's fine, that's understandable. Okay, let's continue and finish our discussion, and then we're going to check the conclusions built upon these assumptions, if they are consistent with the real world data. Okay, if not, then we're gonna come back and manipulate or adjust the assumptions. That's actually how we make academic progress. All right, now so here we already finished our discussion about the aggregate supply of the markets for goods and services. Okay, by these assumptions, we would say that the aggregate supply is fixed. It's Y bar here. Okay. Now on the next slide, we're gonna in the next video we're gonna give you some numerical examples on the returns to scale. Okay, again, help you refresh your memory.